In today's lecture, we'll discuss topics from chapter number 8, which is chemical kinetics, rate of reaction. Now, the rate of reaction, what does this rate of reaction means? The speed of a different chemical reaction varies hugely. Some reaction is very fast and others are very slow. So speed of the reaction is called rate of the reaction. The rate of the reaction depends on the frequency of collision between particles and the energy with which particles collide. So look at these examples. For example, this is the rusting of the iron, which has a low reaction rate. So this process is usually slow. While this is the combustion of wood, which has high reaction rate, and this process is fast. In comparison, the nuclear explosion, this process is really very fast. So in this, you may see there are different rates of reactions. Uh, Now, this rate of reaction is the measurement of the speed in which reactants are converted into products in a chemical reaction. So, change in this, or you may say that change in the selected quantity during a reaction per unit time. Average rate of a reaction is the average value of a rate of reaction over an interval of time. An instantaneous rate of reaction is the rate of reaction at a given time, that are the actual rate of the reaction at that instant. So finding average rate of a reaction is the measure how fast a reaction occurs or how much the reactants or product change in a period of time. So you may see the equation is like rate of reaction is equal to quantity change of reactants or product per total time of the reaction. You may define this rate of reaction as the change in the concentration of a reactant or product in unit time. You may say the rate of a reaction is the decrease in the concentration of reactants per unit time, or the increase in the concentration of product per unit time. And this is the mathematically derivation of this rate of reaction, in which a decrease in the concentration of the reactant or product increase in the product per unit time. So to understand this all, we need to recall this collision theory. What collision theory is saying, it states that in order to react with each other, particles must collide in a correct orientation and with sufficient energy. The particles might be atoms, ions, or molecules. When reactant particles collide, they may simply bounce off each other without changing. So this is called unsuccessful collision. So unsuccessful collision will take place if the colliding particle do not have enough energy to react. If the particle do have enough energy to react, they may change into the product particle when they collide. This is called the successful or effective collision. So rate of reaction is how quickly you create a new substance in a chemical reaction. Faster reactions have more collisions, slower reactions have less collision. So the minimum energy that colliding particles must possess for a successful collision to take place is called activation energy of that particular reaction. So rate of reactions tells us how fast or slow a reaction is taking place. We can measure the rate of reaction in three ways: measuring the time taken for a reaction to complete, measuring the amount of the product formed per unit time, measuring the amount of reactant used up for the reaction, or per unit time it is taken place. So you may compare the different chemical reaction which are occurring at the different rates. These are the fast reaction. How you'll compare this? There's the time taken for fast reaction is short because it would take longer time to complete that reaction, while the time taken for slow reaction is low. So those reaction which takes time to react are slow reaction. So reaction is said to be, rate of reaction is said to be high for fast reaction, while the rate of reaction for a slow reaction is slow. Now let's discuss on factors affecting the rate of reactions. There are so many factors like total surface area of the solvent, reactant, concentration, temperature, use of catalyst, pressure of the gaseous reactant, and light. These are some factors which are affecting the rate of chemical reaction. So first let us discuss the temperature. So when we raise the temperature of reaction mixture, the average kinetic energy, which is the movement of particles, energy of the particles increases. So particles in a solution and in gases will move more quickly around at a high temperature, resulting in more frequent collisions. So the rate of reaction will also increase. Like when you raise the temperature of the system, the molecule bounce around a lot more. They have more energy. When they bounce around more, they are more likely to collide. So that fact means they are also more likely to combine. And when you lower the temperature, the molecules are slower and they will collide less. That temperature drop lowers the rate of reaction. The second one factor is the concentration. So concentration, we usually measure the concentration of solution in moles per cubic decimeter or decimeter cube. The more concentrated a solution, the greater the number of particles of solute dissolved in a given volume of a solvent. So in reactions involving those solutions, more concentrated reactants have a faster rate of reaction. This is because the random motion of the particles in solution result in more frequent collisions between the reacting molecule. So if there is more of a substance in a system, there is greater chance that molecules will collide and speed up the rate of reaction. If there is less of something, then there will be fewer collision and less collision of the particles, and the reaction will probably happen at a slower speed. Now, pressure affects the rate of reaction also, especially when you look at the gases particles becomes closer together when you apply the pressure, increasing frequency of collision. This means that the particles are more likely to react. So, lower the pressure, there is less effective collision, while higher the pressure, the particles come closer and they increase the frequency of the collisions. Let's see the next factor, which is the surface area of reactants. Here you may see example, uh, but let's discuss first surface area of reactant. For reaction in which solvents are involved as reactant, the rate of reaction depends on the surface area of the reactant. Rate of reaction increases with the increase in the surface area of reactant. It is because as the surface area increases, more and more molecules become exposed and available to come in contact and take part in a reaction. For example, if the these finely divided pieces uh, of and these are reacting, these are the more packed one. So here the reactions is slow, as it will take place, but it will take time as compared to when you increase the surface area of the reactant. In short, we may say, for example, another example, like finely divided marble reacts with hydrochloric acid with a much greater rate as compared to the bigger pieces. The big piece, one big piece, and if there are more surface area, they are exposed to react more. Uh, Now the use of catalyst. Now first, catalyst is a substance which speeds up the reaction. It's substance that alters the rate of reaction without being consumed by itself is known as catalyst. So catalyst act by changing the mechanism or the pathway of the reaction and making available into for a new mechanism with the different energy of activity. So catalysts are of two types, like if you say there are positive catalysts and second one is your negative catalyst. Positive catalyst increases the rate of reaction. They do so by lowering the energy of activation of reaction so that more and more molecules can take part in the reaction, while the negative catalysts, which are better known as inhibitors, decreases the rate of reaction by increasing the activation energy. So the only a small number of molecule can have a high energy of activation and are able to take part in the reaction to produce the product. So catalyst is a substance which speeds up the reaction but is chemically unchanged. It remains the same at the end of the reaction. When reaction is finished, the mass of the catalyst remains the same as it is in the beginning at the beginning, and many catalysts are transition matter or their compound. For example, iron is a catalyst in the production of ammonia from nitrogen and hydrogen in the Haber's process. Next one is your nickel, which is also act as a catalyst in the production of margarine or hydrogenation of vegetable oil. So if we are going to going to convert the vegetable oil, they undergo hydrogenation in the presence of nickel as a catalyst and converted into the ghee. So these are some factors which are affecting the rate of reaction.